So lastly, I talked about the bond that held the molecules together. All right, let's continue. Okay, we go over to liquid states. Liquid states, the molecules in liquid states, number one, are not strongly packed together, yet they are not so far apart from each other. Therefore, we say that molecules in liquid states move in clusters. They move in clusters, not so tight, yet not so far apart from each other. They move in clusters. That's why water flows. Do you understand? It pours, it flows. Then number two, the molecules in liquid state move about but not so free. They are intermediate. Anything in liquid state is intermediate, is in between. Then finally, molecules in liquid states are held together by covalent intermediate strength of covalent bond. Not too weak, yes, not too strong. Do you get that? All right, let us go over to gaseous states. In gaseous states, molecules in gaseous states are far apart from each other. They move freely. They are at random. Do you understand? They move far from each other. They are just on their own. They fly about. Then you talk about the movements. The molecules in gaseous states move freely. We have said it before. They are not close. That's the packing. They move freely or move randomly or irregularly. Then finally, they are held by weak van der Waals forces. The bond between the molecules in gaseous states are very weak. All right, that is for molecular explanation of the three states of matter. Do you understand? Now, let us go over to evidences or proof to show that matter consists of particles. Number one is Brownian motion, founded by Robert Brown, a biologist, in 1827. He found out that pollen grain, that's pollen particles, are in constant random motion on water. So if you go through that note, you will see meaning of Brownian motion. That's the constant rapid movement of tiny particles on heavy particles. When you place tiny particles inside heavier or denser particles, the denser particles tend to bombard the light ones such that they will keep moving. So when you look at it, you will see that this has particles. So that is one evidence that matter consists of what? Particles. Number two is diffusion. Diffusion is the tendency of a gas, of molecules, to move freely and fill an empty space due to their random motion. I said that diffusion is the tendency of molecules to move freely and fill an empty space due to their constant random motion. Then finally, law of definite proportion. Law of definite proportion has to do with elements combining in same proportion by weight to form a compound. What does that mean? When you want to form a compound in any chemical reaction in chemistry, if you want to form a compound, what you do is you bring one molecule of this, one atom of this, then you put them together, it will form a compound. Do you understand? So that is law of definite proportion. Then let us explain atoms and molecules. What is an atom? An atom is the smallest particle of an element which can take part in chemical reaction. Remember, according to John Dalton said that atoms are the smallest indestructible and indivisible particle of an element. Full stop. but that definition was nullified by radioactivity and the rest. So as it stands now, the most accepted definition of an atom is that atom is the smallest particle of an element which can take part in chemical reaction. It is no longer indestructible and indivisible. No. All right. Atoms has particles. They have atoms have electrons, protons, and neutrons. Electrons are negatively charged. Protons are positively charged. Then neutrons have no charge. Electrons are at the shell. That is if you are using Bohr's theory, Bohr's atomic theory. Electrons are at the shell. Protons and neutrons are in the nucleus of an atom. All right. After this, we will now talk about molecules. A molecule is formed when two atoms come together. That's two atoms make one molecule. So we define a molecule as the smallest particle of an element which can have separate existence and still retain the properties of that element. Is the smallest particle of an element which can have separate existence and still retain the chemical properties of that element. A molecule is very small, and the diameter of a molecule is about 10 to the power minus 9 meter. Very, very small, 0.000000008 zeros. So it's very, very small. Then if you divide it into two, you will have the diameter of an atom. This is very, very, very small. So that is the size of an atom and that of a molecule. All right, somebody will say, I want to see the structure of an atom. Yes, I will also send you a link where you will see the diagram to these notes, because we can't draw everything in one note or in one section. We can't do everything in one section. So you will see a diagram of where you will see the diagram. For instance, atomic structure, you're supposed to see the diagram. The packing of the molecules in solid, liquid, and gaseous states, you're supposed to see the diagram. So I will send you a link. That link is for the notes, where you can copy these notes and you can also draw the diagram. Is that understood? So if you have understood the lesson, let me evaluate you. Number 1, define matter. What is matter? Give me an answer in the comments box. What is matter? Number 2, mention the 3 states of matter. I want the answer in the comment box. Number 3, mention 2 evidences of particulate nature of matter. Don't copy. Tell me what you learned from the lesson. Don't copy. Number 4, what is an atom? Explain an atom. Explain molecules. Briefly explain atoms and molecules. Then I have assignments where you can now carry on and furthermore in this lesson. Thank you very much. This is where we'll draw the curtain for today's lesson. If you like our section, please give us a thumbs up. If you like this channel, you subscribe for more videos. Click the notification bell. That's the icon, the notification icon, that bell. Click on it so that whenever we drop a video, you will get notified.